Let's take a look at solving some inverse trig problems that seem at first glance to be really easy, but have a little bit of a trick to them because of what they do with our domain. So we begin with this part of our problem. Cosine of theta equals pi over, or equals 0.4. And so we're going to solve that. It seems really easy. To find theta, we're going to do an inverse cosine. I'll be in degree mode because they want degrees. I can see that over here. So the inverse cosine of 0.4, and using a calculator, I find out that theta is going to be about 66.42 degrees if I round that off, which is all well and good. However, if I take a look at how they wanted the answer to appear, they wanted the answer to be between 270 and 360 degrees. So the angle does not satisfy that requirement of the problem. Remember, there's an infinite number of angles that have a cosine of 0.4 because they can just repeat in the circle. So I need to find a different answer. My calculator will only give me one answer. I want to find a different answer. So here's what I'm going to want to do. Let me make a sketch of what's going on in this problem. We just found our angle, the angle the calculator will give us, to be 66.42 degrees. So it's somewhere here in quadrant 1. And that angle will always be in quadrant 1 for what we're doing right now. Or possibly a different quadrant, but it's not going to be this quadrant I want it to be in. So I need to adjust my angle. Basically what they're telling me is I want to be in quadrant 4, between 270 and 360 degrees. So let's take our angle that we found and just kind of insert it into the quadrant I want it to be in. I want it to be measured right there. I want that measurement to be 66.42 degrees, always with the x-axis. But I don't measure like that. I always measure in standard position from the positive x-axis counterclockwise around to there. So the trick to doing these problems is put the angle that you found where you want it and then measure it as you're supposed to measure it. So there's a few ways I could find out what that large green angle is supposed to be. What I see is that I make almost a complete circle. I make almost 360 degrees, but I don't quite get there, so using some simple geometry, I'll, in this case, subtract off that angle. This depends on what quadrant we're in, so don't think you always do angle minus 360. Subtracting this gets me an angle, then, of 293.58 degrees. So that's the angle, then, that we want in the quadrant we want it to be in. It's really simple to check these, and I'd recommend you do that real quick, because they're very simple to do. There's two things you want to check for. First, is the angle between the two values they said? Is it between 270 and 360, and 293 is, so check that part works. Also, we want to make sure that if I plug this angle back in, does the cosine of 293.58 degrees equal 0.4? And if you check that on a calculator in degree mode, it comes out, yeah, pretty darn close. It's not quite exactly because we rounded it off, but that angle is going to work. Okay, let's take a look at one more example just to make sure you've got the idea. This time, they want the answer to be between 90 and 180 degrees. In other words, in quadrant 2. We're going to see that when I use a calculator, it's not going to be in the quadrant they want it to be, and so we'll have to adjust it. So to find theta, at least to find 1 theta, I have to do the inverse sine of 0.62, and I find out, according to my calculator, the one and only answer the calculator will give me is that this angle is 38.32 degrees, which is the answer, one of an infinite number of answers, the only one the calculator will give me, but I'll need to sort of manually adjust it to end up in the quadrant I want it to be in. So again, let's make a sketch of what's happening. So this angle is 38.32 degrees. Remember, it's always measured from the x-axis. I don't want it to be in quadrant 1, though. I want it to be in quadrant 2, between 90 and 180. So let's sort of insert the angle where I want it to be. I want it to be in quadrant 2. So let's kind of copy it over there. So instead of that being 38.32 degrees, I want this to be 38.32 degrees, which is great. However, that's not how we measure an angle. We always measure from the x-axis counterclockwise around the circle. So that's the angle that I want to find. Using some simple geometry, I can see that I go not quite 180 degrees, because that would get me halfway around the circle. I do 38.32 degrees less than that. So I've got to do some simple geometry to figure out the angle I want it to be. Once I subtract those, I come up with an answer of 141.68 degrees. Make sure you've got that degree symbol on. And since these are so easy to check, let's just do a quick check of this. First of all, it is between the two numbers I said it should be. It's between 90 and 180. Also, when I do the sine of 141.68, that should be equal to 0.62. And using a calculator, I can see that, yep, it comes out really close to that.